And people might say, oh my God, well, that'll kill pure science. You have to make it all, accessible. And so I'm like, look at Veritasium, look at 3Blue, 1Brown, look at some of these science, channels on YouTube. There's an audience for it. And actually, there's a fairly well-heeled audience that wants to learn about this stuff. You could actually monetize your teaching now, for example, and use that to fund research. Basically, a lot of these open funding models, I'll probably write I just went through several of them right there.
Hey guys, Alex here. This is episode 2 of the DeSci podcast, and it's a special one. Balaji Srinivasan is an angel investor, tech founder, and author of The Network State. Formerly, he's the CTO of Coinbase and general partner at Andreessen Horowitz, and he's also an early investor in many successful tech companies and crypto protocols. Balaji was the co-founder of Earn.com, acquired by Coinbase, Council, acquired by Myriad, Teleport, acquired by Topia, and CoinCenter. He holds a BS, MS, and PhD in electrical engineering and an MS in chemical engineering from Stanford University. I'm also happy to be joined by Vincent Weiser, who's chief of product at Molecule and VitaDAO. Today we spoke about scientific progress, the future of human optimalism, the helical theory of history, and how to make predictions. Hope you enjoy. Yeah, so why don't we do that? For many, I think you need no introduction, but for the sake of anyone, I guess I'd say unindoctrinated, why don't you give yourself a quick intro, plug the book before we get into all the juicy stuff, and we'll be off to the races.
Sure. So, but how's my audio? Good?
Sounds great.
Great. Okay, good. So I am, my name is Balaji Srinivasan. I am twitter.com/BalajiS and BalajiS.com. I am the former CTO of Coinbase, former general partner at Andreessen Horowitz. In a prior life, I was a career academic. I taught computer science and stats at Stanford, got my PhD at Stanford. I mention that much less nowadays simply because I'm so bearish on academia, and I kind of think that era is ending and the new era of decentralized academia, decentralized media, decentralized science is beginning. And we can get into that when we talk today. I have a new book that just came out called The Network State, and it's at thenetworkstate.com. It actually intersects with many of these things because the way that the nation state justifies itself is it says that everything it's doing because of science, right? Quote unquote science. And, as I'll get to, there's a huge difference between science in the sense of Maxwell's equations, which are independently reproduced, and quote unquote science in the sense of just peer reviewed publications, which are often not independently reproduced or even reproducible. And it mimics the form, the journal publication, the citation, and the prestige and so on, without the substance, which is the ability to do an independent replication. And this is this core difference between quote unquote science and actual science. And one of the things I actually think about and I talk about is there's actually only one thing that's more prestigious than science. You know what that is?
No.
Math. I know that sounds almost trivial, but we don't normally think of them as opposed, right? The king and the queen of, like STEM, right? They are together, STEM, science. How could you have math? But one way of thinking about it is crypto economics is based fundamentally on math. It is based on the fact that we can go and download the Bitcoin blockchain and run a bunch of mathematical computations to verify all the past transactions. Same with the Ethereum blockchain. And that's different than academic economics, which claims to be based on, quote, science, where it has got into this realm where you cannot verify everything, all right? And it's become this sort of priesthood, this prestigious priesthood. And as I'll get to, I think many of the concepts behind, the difference in crypto economics and, legacy economics or fiat economics can be applied to, crypto information versus fiat information. Are you taking some non-reproducible thing on faith, on the assertion, the fiat, of the state or of some state-associated institution? Or is it crypto in the sense that the data set, the calculations, the code, everything can be downloaded and reproduced locally? And this, by the way, is I'll return to these topics, but it's a long-running strand in Western culture that when the centralized thing is ossified and it is unresponsive, you break the glass and you decentralize. That's what Martin Luther did when he pinned the 95 Theses to the door of the church in 1517. He was saying the Catholic Church has become ossified. Actually, faith comes just through the Bible. And this was, we think of it as a theological thing, but it was also a political thing where he was decentralizing power away from the church to individuals, and of course began a whole conflict over who has the authority or what have you. But that is what crypto is doing, is it's decentralizing that power, that verification, who has the authority to say what's true, away from the government, away from the Federal Reserve, and now I would argue away from academia, and to the individual with their computer or their mobile phone who can run the calculations for themselves. So the network state actually, I have to add more, I've got the V1 out there. That's how I think of it.
Right.
I have the director's cut coming, where I've got a bunch of stuff on this kind of topic, like what I call the ledger of record on regulation and so on. And those are like 50 or 100 page chapters that I kept out. By the time it's done, it'll be quite long, but I think it'll be of interest to a lot of people. All right, so let me pause there. That's the book. It's free online, thenetworkstate.com. You can also get a PDF in LaTeX if you want that, and you can get it on Kindle. We'll do a hardcover and Audible, but you can go there. If you subscribe, you can you'll get free chapters, blah, blah, blah. So it's all free online. Okay, go ahead.
Excited for the hardcover, by the way.
Go ahead.
Always a big fan. Just excited for the hardcover. I'm always
a big fan. Sure. Yeah. That we're gonna try and make that copy like a work of art. I think the online version is pretty decent, but we can improve if you have feedback. But we're gonna try to make the hardcover like really like a mantelpiece kind of thing. So
love it. All right. So to start us off at sort of a macro level here, given, as you mentioned, your pretty robust academic foundations, that BS, MS, PhD trifecta from Stanford, I think I
also have an MS in chemical engineering, for what that's worth. So, so I have so anyway, whatever. So I've been in academia way too long. So I know a little bit about it. Go ahead.
More than a trifecta then. I think you'd have an interesting research perspective here. What do you think are the key factors holding back scientific progress globally?
I think the entire Vannevar Bush thing of centralizing research around and after the time of World War II has run its course. And so I think the fundamental thing holding back scientific progress globally is the choke point that is the US government. And what I mean by that is, you'll often see people say, oh, basic research has to be federally funded. What about, the internet and the human genome and so on and so forth? And it is true that there's been some great stuff that's come out of what I'd call the centralized, research establishment. But Bastiat has this concept of seen and unseen. And there's this concept also of crowding out. So all of these funds that were appropriated and centralized with the federal government, all the research that was centralized there's a certain school of thought that comes where it's, grants and it's papers. There's choke points that happen. And if you've seen, there's a graph that Collison has posted that I've also posted a while ago, which shows that the same cohort that started receiving NIH grants has basically just aged like roughly 1 year per. Do you know the graph I'm talking about? You might be able to show it. Okay.
Absolutely.
It's, NIH, let's see if I can find it. NIH grant recipients. Yeah, here it is. It's kind of like, it's this. This gives a concept. So if you go into that and you scroll down a little bit, do you see the fiscal year, the blue and the red thing there, right? Basically, as the years go by, that mode of the bell curve just shifts over roughly 1 year at a time. And so it's like the same cohort of people who are on each other's grant committees that are awarding themselves stuff. And they're just sort of aging with it. It's a very political, centralized process that is ossifying, along with much of the rest of Western civilization, where you see, Top Gun Infinity, you see, like 70, sometimes 80-year-old politicians. Patrick Collison actually had this tweet just a little while ago. Let me see if I can find it, which shows that this is the case for movies. This is the case for, here we are.
We'll put these links in the show notes for anyone listening on audio.
Yeah, here you go. So take a look at that one. See that? Look at those two graphics. And the first one shows that movies with leads, less than 30 years old were very common in the 90s and the 2000s. They're incredibly uncommon today. And now 60-year-old, why is that? Because people are like, oh, remember when America was better? And, they want Tom Cruise. They want, these proven stars, but those guys are aging. You go to the next graphic and you can just see like the age of NIH investigators has dropped off. And that saying, like, which is, it's like science advances one funeral at a time. If you've heard that, like, it's very, like, obviously it's very cynical, but it's also true in the sense that often things are not, the old guard doesn't want to retract something or want to give in, but when they're no longer there to fight it, then like there can be progress that's made, and to your question, that centralization, the one thing that happens is you'll get people like Mariana Mazzucato or others who will say, "Oh, all innovation is due to the state," and what about DARPA? Why don't you give thanks to the great glory of the state for taking and taxing all the money from you and then dribbling a little bit back to you in the form of research dollars, right? And the thing about this is, if you go a little further back, obviously much of mathematics and physics was discovered before NSF existed. Like Maxwell's equations was not NSF funded, and neither was Newton. There are, if you go further back in time, in fact, thermodynamics and statistical mechanics came out of experiments and the empiricism of steam engines. Like the engineering drove the science, and there's these huge industries of railroads and aviation and automobiles, which obviously involve quite a lot of science, but also a lot of engineering, that managed to arise without something like the kind of federal research establishment that we have. I'm not saying there wasn't some federal funding for railroads and stuff like that, but fundamentally the thing was more decentralized. The reputation system was decentralized. The funding system was decentralized. You had the time, the so-called gentleman science, where people would get independently wealthy and they would tinker and putter around with stuff and they'd publish sort of for each other, right? Now today, that actually is sort of coming back with open source, with the fact that people can putter and they can try things out and they can share their results online, and they can even do so pseudonymously. And it's not just gentlemen, but it's gentlewomen and gentle pseudonym science, like the project-evidence.github.io or Satoshi Nakamoto's white paper. Those are things which, while they're now very highly cited, at least certainly the Satoshi Nakamoto Bitcoin white paper is very highly cited in traditional academia. It's probably not the kind of thing that you could easily get published in traditional academia because it spans so many disciplines. It's not thought of as a good concept, but you could put it out on the internet. And, project-evidence.github.io, that's now almost conventional wisdom. I tweeted about this in, March, April 2020, which was basically evidence for lab leak thesis when that was highly, controversial. Oh my God, conspiracy theory. Now it's almost conventional wisdom. Right now that basically, it's politically useful. It is almost conventional wisdom, but it's not so much that the facts have changed. The trail in some ways has gone colder. So to your question, the key factor is centralization, and that might have actually had some benefits. Okay, in some sense during that period, that may have also been in a sense inevitable. 1950 was arguably peak centralization. I talk about this in the Network State book. You had one telephone company and two superpowers and three television stations, or rather, you had AT&T, right? You had the U.S. and the USSR. So one telephone company, AT&T, two superpowers, the U.S. and USSR, three television stations, CBS, ABC, NBC. That was highly and aberrantly centralized. You had these massive empires, the Soviet Empire, the Chinese, like everything had just massively centralized into these Geiger states. And really under the US and the USSR. And then the third world was, those parts that weren't, or some of them were actually actively fought over, but they were not combatants themselves. And this degree of centralization was actually very atypical if you go backwards and forwards in time. So this whole thing of the centralized scientific infrastructure that we think of as just a fact of nature actually arose within living memory. It might be older people, but it's, if you're 80 something years old, you were around before this whole thing was basically set up. And so we need to actually not just get rid of that, we need to transition away from it gradually and transition into something else. And so then that gets to, I think, your next question.
Right. Which is, in that same vein, let's suspend our disbelief for a minute and pretend you had full control, right? We're playing God here a little bit. How would you change that legacy research and funding structure?
So, this is like, the NIH budget is actually pretty large. It's several $1 billion a year. Much of this is now starting to be taken over by people doing Thiel Fellowship like things and getting academics out to kind of just go and do tech startups. So several different things. First is, I think it's somewhat framed incorrectly. This, and I'll just kind of contest a little bit the framing of the question, which is,
Sure.
It's a little bit like, how would you allow India to flourish if you were in control of the British Raj in 1940 something, right? And my answer is, I'd free India, right? I'd let India be free, and I'd let them, go and, build up their own country and do it independently, right? And so, if given full control, I would give up full control. Okay, and how would we do that? Essentially, what you want to do is shatter the entire thing into many different funding sources. Like the thing about this is, are you going to be able to break NIH this way? You're not, right? I don't actually. So it's almost like not a very useful thought experiment. What I do think, just like I don't believe you can abolish the Fed like Ron Paul wanted, I do believe you can exit the Fed. Okay, and NIH is this giant jobs program, and NSF is also basically like this but smaller. And the thing about it is, all these people are paid as lab techs that are basically doing the job that a pipetting robot should be doing. All of this stuff is almost like artisanal science, where why is it not reproducible? Lots of bench science should be a program that is run by essentially something like, digital or analog microfluidics or a pipetting robot, and it should not be run by a human. There should be much, much more effort on bringing down cost, increasing reproducibility, increasing automation. The fact that we have had this huge subsidy for like the, 40-something postdoc who's basically like a pipetter, is part of which has inhibited laboratory automation, I would argue, because the imperative isn't there quite as much. You have these people who are sort of promised academic jobs and dangled in front of them that status and independence pay off, and they basically never get there, and they're embittered and they're adjuncts or whatever for the rest of their life. And that whole thing where you're kind of dangling something at the end where the pipeline doesn't really fit is, I think, something that's reaching end of life. And so what are the kinds of things that you should fund? Not perhaps, I don't think it'll be within academia. I think it's going to be outside of academia. I think it's going to be like crypto science, decentralized science, where we pool capital and fund things. What do you fund? You basically fund independent investigators, and you fund relatively low cost. Maybe it's like 1 to 3 years. And unlike the traditional academia, you don't have to write a grant where basically everything is done beforehand. Traditional academia, when you write a grant about some receptor, people are so skeptical that unless you've actually done the science already and you've shown it there. So you end up kind of saying, oh, I'm going to do something that you've already half done. And really the grant is for the stuff you haven't done yet, right? And then that gets booked forward. So instead of doing something like that, just go the much more honest VC/startup model. And you can do something like the Thiel Fellowship, where you fund somebody for, and by the way, I might be interested in doing this, myself, in the not too distant future. And we'll test it and see if it works. But the concept is, you find somebody who's smart and young and they're interested in something. I funded somebody recently who's working on artificial wombs. I funded people, so a woman who's interested in doing that because of, she's passionate about infertility issues. And, I think that's an important thing to work on as well. I funded, people who are basically doing these sort of one-off things that you probably wouldn't get funding for in academia because they're too crazy or too innovative or what have you. And I think that what you do is you give people like maybe a 1 to 3 years of funding. Okay. And it's usually like one person or maybe like a very small group. And they're trying to do the basic science and prove it out. And then if it works, that technological fire, catches, then they start a company or they turn that into a company. Okay. And if it doesn't, then, like they either find somebody who wants to continue the funding or they shut it down. Or they, figure out some way of funding it, from like selling NFTs or something like that. These are new models that are now available, right? And every job at some point has some sales component. You just don't get money for free. In academia, it's a grants mechanism. But once you're in an open world and you can get money from basically anybody, not just academia, guys like, Andrew Huberman or David Sinclair, they're kind of like pioneers here. They're starting to like monetize in public. The scientist influencer who you have to explain your work. That's the whole point of publication. If you also devote some of that to making kind of cool videos online, explaining the social importance of it, that's good. And people might say, oh my God, well, that's, that'll kill pure science. You have to make it all, accessible. And so I'm like, look at Veritasium, look at 3 Blue, 1 Brown, look at some of these science, channels on YouTube. There's an audience for it. And actually there's a fairly well-heeled audience that wants to learn about this stuff. You could actually monetize your teaching now, for example, and use that to fund research. Basically, a lot of these open funding models, I'll probably write I just went through several of them right there, but just to recap, you can set up a company and get it funded. You can try to do crypto style funding, whether it's DeSci and crowdfunding or it's NFTs or some combination thereof. You can become like a science influencer and get subscriptions. And like Veritasium and others are showing this actually a much larger market. You could even set up like job dashboards and stuff on your page. If you're like a physicist, then, the kinds of people who are reading your blog or reading your publications are going to disproportionately be people who are, have skills that others want to employ, or that others want to find, and so on and so forth. So there's a bunch of different ways of kind of doing science outside of academia. And so how to change the funding structure? I would look for outside academia funding, decentralized funding, and fortunately, those things are coming online.
Gotcha. As something of a follow-up there, you talk about legacy media outlets, sort of enablement of decentralized censorship, of cancel culture, of American empire, all of which I think you'd reasonably take issue with. And we can unpack that a bit. But the question I have here is whether you think there's a reasonable connection with academic journals' gating of open information. So more simply, are there commonalities between the New York Times and Nature, the scientific journal, for instance?
Yeah, absolutely. And the thing is, academia moves slower than legacy media. It has, the thing is that of the pre-internet power centers of the U.S., like, DC, which is regulation, Harvard, which I'll use as a metonym for academia, Hollywood, which is film, New York, which is media. DC and academia and Hollywood even take, years to multiple years to turn something around. A paper or a film, or especially a rule or regulation that can take multiple years to turn something around. Media had a 24/7 metabolism, CNN and others, like media is used to shipping a newspaper every single day. So they were the only legacy, institution that had the same metabolism and speed of people who are deploying on the internet. So they became sort of the point of the spear of the establishment against these tech interlopers who were rising first in Silicon Valley and now I think globalized. Okay. And, so legacy media basically had, they're attacking everybody. They're attacking, every country, every movement within the US, everything that possibly could contest the US establishment, whether it's France or Hungary or China or India or Russia or conservatives or centrist liberals or tech people or crypto people or whatever, right? There's like a new enemy every single day. And when you start actually adding all those up, you're like, oh yeah, I guess they have kind of denounced all of them. You might agree with one or two of them. You might say, okay, well, look, China's actually getting pretty ultra nationalist here. That's like a real thing. But when everybody is denounced, other than like, the New York media establishment, everybody's, and even them, half of them are denouncing, like that just becomes something where, okay, well, if everybody's bad, maybe this guy is bad, or maybe these people are actually just pointing the finger at everybody other than themselves. And, so legacy media has been more out in front in terms of pointing at some poor guy online who's made a joke and driving them from their job. Academia hasn't, you don't have time to publish a paper on the metabolism of Twitter, right? But the connection with academia is the slower moving stream that the legacy media will cite if pressed. Why? Because science. Okay, because Nature, because Cell, whatever. Okay, and just a play on words. And the thing is that fundamentally, this is the stream that is supposed to determine what is true for people. What is it true? Well, it's in a peer-reviewed publication. What more do you want? Okay, and so let's go and decompose that because that's really important. Basically, the fundamental high-level thing is that science is about independent replication, not prestigious citation. So you start there. Unless I can reproduce every aspect of the experiment, every single graph and table in the paper, ideally nowadays with a keystroke, I do not believe the paper. And that's actually the minimum thing, because when a paper is released, it is making claims often about the physical world. There's math and stats papers, which you can do wholly on the computer science papers you can do wholly on the computer. But those that have collected a data set, you can sort of divide it as there's the analog to digital interface, which is the collection and encoding of the data set. And then there is the process of taking that data set, writing code to generate the figures and tables and the PDF that makes up the paper, right? So at least the digital layer, let's talk about that for a second, right? That digital layer should be truly reproducible research. And the concept of reproducible research, perhaps, John Claerbout and David Donahoe at Stanford in the early 2000s have taught about this for a while. R has a Sweave package. Many people have used Jupyter notebooks. Okay. And the basic concept behind reproducible research is you don't just give somebody a PDF, you give them the, tar file or the source code where they can hit enter, and they've got the local database. It could be a SQLite, it could be just a bunch of flat files, whatever, but they've got the data there, and they hit enter, and the code slurps up all those files, it makes the graphs, and it generates a PDF, right? And the reason this is so important is you can see, people can't necessarily have the words to describe every single parameter they used, right? They don't necessarily have the words to describe certain hacks they did on the data or how they cleaned it up. All of that, though, is there if you actually trace through every step of the source code. And it does something else, which is very useful. It trains grad students because you can be like, look at the source. How do you do that figure? You can do this one. And then in a future paper that builds on this, you could import that. Okay, so that's reproducible research. The next step is what I call truly reproducible research, where that code and that data and that PDF is not simply like online, it's on chain. Why put it on chain? Well, first is that gets you outside of academic paywalls and stuff. It's actually truly public, number one. Second, it's immutable, or it's very hard to mutate. And there's a track record of it being mutated. So it's the aspect of archival publishing, people are starting to pull down papers. Wired had this thing, which is like, oh, they're pulling down papers finally, right? And they're like celebrating the fact that they are defacing the archives. Here, I'll show you this. Of course, it's always framed as Xist or Yist, but it's like getting rid of harmful papers is a vital step toward reestablishing trust. Next, publishers should target articles that are flawed in other ways. So they are truly 1984ing it. Okay, and they'll basically go with the edge cases and then start moving in from the edge and moving in from the edge. And this article is not found, right? Now, if you did this in the Soviet Union, it would be obvious that this was not a good thing. Even if it's wrong, have it out there so people can see that it's wrong and how it's wrong and critique it, as opposed to deleting it and unpersonalizing something that was, quote, published, right? So what's happening, so basically the truly reproducible research will stop this from happening. Most people don't even know this is happening, that the archives are getting silently purged. It just doesn't come up anymore in PubMed. This is very damaging to the historical record. This is why stuff like Sci-Hub is so good. I mean, you'll know that the system is being fixed when Satoshi, Snowden, Alexandra Elbakyan get Nobel Prizes or the equivalent, right? I actually think the Nobel itself is a broken prize, by the way. Like it's, quote, Eurocentric, right? Whatever the next prize is, I think will be some kind of Satoshi prize, some, like global decentralized pseudonymous prize where it's like awarded, on chain, and it's for work that is reproducible and so on. I'd love to do something like that at some point. So coming back, so truly reproducible research, the data would be on chain. The code to turn that data into the PDF would be on chain, and the published PDF could either be on chain or with one, enter regenerated from that. And when I say on chain, by the way, it could be Arweave and IPFS. I don't necessarily mean like you literally need to store it on Ethereum, right? What I mean though is that you have immutable storage, public storage of the thing, right? And here's where that gets interesting. Why is that interesting? Once you start doing this for enough papers, a citation becomes a function call. Okay, because when you're citing an old paper that you actually are using directly, that analysis you might actually be able to just literally use it as a function. You're importing that old paper and you're using that to generate a graph that you're modifying in this paper. Okay, especially for stats papers, especially for bioinformatics papers, methods papers of many kinds, computer science papers, machine learning papers. a fairly large set of things can literally be used in exactly this way, where the later version, for example, you're doing a benchmarking here, you want to make sure that you're being fair to the other authors. You literally import their module and you function call that with your data set, and you've got that in the code so people can see you're not playing any shell games with your benchmark. Benchmarks are that's a very common thing, and that's like a good example of what I'm talking about. So when a citation becomes a function call, that's possible because the network of papers starts to be on chain. And then you can start doing all these meta things. All of Google Scholar, only Google can do Google Scholar. Why? Because all those papers are, behind like academic publishing sites, right? Someday somebody will probably do something like Sci-Hub and just put all of Sci-Hub on a blockchain or something like that in public. And when that happens, that's like this, liberation of all of this old content. And then you can start actually backtracing it, where the 30 papers that this paper cites, you can see them, they're on chain at this timestamp. It goes back to 10 papers, and you can trace it all the way back, ideally to like Newton or Maxwell or something. And here's the thing that you'll often find when you actually trace back the citations. Many things that we think of as sort of like physical laws are just function fits to curves. And the raw data there is like 5 data points or whatever, okay, in a paper in the 1930s or the 1800s or something like that. And then it's just kind of it's like lore, it's like passed down. There's a story of spinach and how it's supposed to Popeye spinach, helping muscles or carrots helping eyesight. These things become apocryphal, and they are spread or picked up in scientific journals, and each guy cites somebody else, but no one actually has the original paper because it's too hard to find it. And you track it all the way back, it might not say something like quite what it says. And this is particularly important in like medical studies. So having everything, first you get an individual paper on chain, that's still useful. It's reproducible. It's truly reproducible this time. Then you start getting a constellation, a network of them. And then you start turning like citations into function calls. Now you at least have done something very important, which is the digital part of the paper can at least be replicated on your computer locally. There's Benford's law, there's various statistical tests you can run. George Marsaglia, when he's looking at like random number generators, has a thing called like the die-hard battery of random number tests. You can run basic checks on this type of stuff for fakery, which is unfortunately more common than one might think, okay? For faked or massaged data sets and so on. You can run consistency tests, say, are they actually getting this graph given these inputs? At least you can test whether it's logically consistent. This is the kind of stuff that any VC associate does when evaluating a deal. They'll just try to add up the rows and the columns to make sure that they can back out the same revenue number a few different ways, And if not, there's often some inconsistency, okay? So that would be one of the things you can do with truly reproducible research. You can at least look at the digital part. Now, what people will say is, well, what about the actual physical measurement, right? You're just taking the digital part and you're just trusting that. Well, I'd say 2 things. First is everybody doesn't have, like an Illumina sequencer at their home. You don't have a HiSeq at home. You don't have, a incline plane. You don't have a superconducting super collider. You don't have those things at home. Okay. What you do have are computers and mobile phones, which can do billions of calculations. We have AWS and other things that anybody can rent. So at least the mathematical part, let's at least get on base with the digital part, and we can check that. Now, for the physical part, what I think you'll go to is eventually you'll get what I call crypto instruments. And right now, if you've done any genomics, like the file that's uploaded has all kinds of metadata on it, and you use it to check for things like batch effects, right? Because you sequence today, you sequence tomorrow, you sequence the next day, and you might find that there's some spurious correlation where these samples seem to have this signal and the next day sample of the next signal. And you always have to correct for batch effects. So it's very important to track all that metadata with your sequencing run. Which machine was it on? Which day was it on, et cetera. And just make sure that you're not actually backing out of your sample the machine idiosyncrasies, okay? Which sometimes people can do a regression and they think it's a real signal and it's not. It's actually just like, the different machines had a slight shift in like luminosity or whatever. And so it's already typical to record metadata on these biomedical experiments. And so what I say is you record just a little bit more metadata, which are Merkle trees and Merkle roots that hash certain pieces of the data to give a digital chain of custody. Okay. So now as the stuff is streaming off the instrument before it's analyzed, before it can really be faked or messed around with, that is like put on chain. And you kind of have something already with this with like registered clinical trials, right? There's certain kinds of experiments that are important enough that they're pre-registered, and you're doing the experiment so that whatever the results are, you're going to report it, and so on and so forth. Okay. So if you're doing something for publication, sometimes there's courtroom settings where people film it just to make sure that everything was on the up and up, right? And the thing is, if you're basing multi-billion, sometimes multi-trillion dollar decisions on a paper, you need to have like respect for the people on the other end, that they are allowed to reproduce every aspect of it, all the way down to like the sensor data from that instrument. Okay. Otherwise, it's just a proclamation from a priesthood, right? It's not science. If you can't reproduce it without trusting the guy, like you want to minimize the amount of trust. By minimizing the amount of trust, by being open kimono, right? By being as honest as one can be in distributing all of the data and so on, and saying, look, this is everything. Here's even the video of it, and so on and so forth. Here's the commands to rerun the experiment on your automated pipetter or your HiSeq, whatever. Like, now you've at least, you can say, what more could I have done, right? I have given you all the tools to reproduce the experiment. And that's the kind of thing that rebuilds trust. Not, I'm a scientist, it was a prestigious journal, I need this for my promotion, which is basically where people are at, because retractions are so career damaging that people don't really want to make corrections or retractions. And compare this again to, like, as I said, the open source culture, where on a GitHub repo, it's assumed, even on the Linux kernel, even on the Bitcoin repository, how many open issues are there? Like, without even looking, probably dozens, if not hundreds, right? These are massive projects everybody depends on. And even then, people understand their works in progress. Okay. That kind of modesty and humility is not there in academia, where things that are used by far fewer people and that have far fewer of a base to stand on have to pretend that they are, from like Athena's head, like fully born, right? Or actually, Athena was born from like Zeus's head. Sorry, I got that mistake. So like this truth is fully born. And it just it's not how it is, right? So putting all the pieces together, truly reproducible research means the digital part, the code, the data, the paper are on chain. When that happens for multiple papers, a citation becomes a function call. Anybody can now reproduce both the paper and its antecedents on their computer. They can do checks like Benford's law. They can do statistical checks. And that's a digital part. And then for the analog digital part, which are the instruments, eventually we get crypto instruments that start recording Merkle trees, Merkle roots with the other metadata that they're already recording. And now you start to get a digital chain of custody on these papers and on our entire scientific apparatus. Now, what I've described, by the way, there is a difficult but finite problem on par with Wikipedia. I say we have to get the backfill of all the important papers into truly reproducible research format. And then we need to have front fill being new papers, right, that are on chain. Okay, go ahead. I know there's a lot.
Yeah. I'm curious, like, how you think, like, imagine like all of this like works in this build, like science being upstream of most like scientific, like technological progress. How do you see it, like in general, like scientific progress unfold? Like, do you see like machines taking over at some point, solving all these diseases? Like, I would be curious, like your vision for kind of like how decentralized science and like science broadly like will transition to kind of like this age of like AGI, etc., like doing more and more of the work and like cloud labs, etc., taking off. Like, how do you see that future unfold?
Yeah. So one big thing is I think replication is massively underestimated as a driver of the use of science. Just as an example, like you guys have used tons of GitHub, based open source projects. What do? You'll download it, you'll run it. If it doesn't run on your computer, it's an amateurish project. And, like how many times do you quote replicate their claims? You're literally executing the software. And if it doesn't replicate or work on your computer, it's useless, So like some, software is quote replicated literally, I don't know, millions, billions of times, depending on, Rails, how many times, Python, Django, whatever. The replications, in a sense, being able to run it locally are massive. And once you get science as being something that you can think of as a component of your software infrastructure, where there's not like, here's the paper and there's like a human transducer that needs to somehow pull it onto their side. Once that's actually considered like a component of it, just like what crypto has done, the concept of like composable finance.
Yeah.
Right.
Yeah.
Composable science where papers are composable with each other. The key subroutines are composable, just saves everybody just insane amounts of time. It's like, it is completely nonlinear, because you've now got a library of things. Wow, I can actually, all of this work is being put into these artisanal papers that are just like effectively scans of what was offline, and they're not built for the machine, they're not built for the computer. Okay. So that's like the broad concept of why I think this would accelerate things. And then, now you asked a specific question. You want to repeat that specific question?
Yeah, kind of like how you see kind of like the most optimistic visions of cloud labs, AGI, et cetera, like influence science, like kind of like,
well, AGI
take over and do science.
There's a friend of mine who's been very bearish on AGI. And eventually I was able to figure out a bet with him. And I was like, okay, you agree that artificial special intelligence exists, even if not general intelligence, like domain specific. And he's like, yes. And I was like, okay, how about math? Okay, we are seeing language models do all kinds of interesting symbol manipulation. We're seeing things like, forecasts of the state of PDEs. Obviously, we're seeing things like DALL-E 2 and so on. Will you bet me that AI will start to advance math problems and get proofs that we have not seen before that humans can check, right? And he had to agree that while, and so what I'm talking about is like literally advancing the state of human knowledge with proofs that are better than one that are human, because it's a formal system, right? Depending on the area of math that you're talking about, in theory, it should just be like, a search space through the whole thing, unless you're introducing some new symbols or what have you, right? Obviously, the machine representation is a non-trivial thing, but there's symbolic algebra packages, and Mathematica has been working on this for some time, and that area exists. So some of the affordances for the computer exist. And I actually did see something just recently. So it was like a first for AI math. Where is this? It's just very recently. A new computer program has solved several open problems in combinatorics and graph theory, right? So that's pretty legit, right? Once you start getting, this is similar to the four-color map problem, right? From a long time ago. That was like one of the first computer-aided proofs, right? And it was controversial, but because, could a human verify all those different combinations in that amount of time? In theory, yes, but the computer helped, right? It was like, I forget the exact statement. It was something like, I think there was a shorter proof. Four-color map theorem, can every 2D map, be, four-color map theorem states that no more than 4 colors are required to color the regions of any map so that no two adjacent regions have the same color, right? And so Appel and Haken, proved it. And then, this was also proved in 2005. I didn't see this part with general purpose proving software. Okay, so coming back, AI advancing the state of math, pretty big deal in my view. I mean, honestly, in a sense, like, what is your ruler for the progress of civilization? The progress of civilization is kind of how good are you at math? That I think you can think of lots of other metrics. I think the Kardashev scale is probably the other good one, which is the amount of energy you can manipulate, right? Like, subplanetary or like solar system or whatever. But the amount of math you can do probably pretty closely correlates with that. You're probably not going to be like as a god manipulating the stars unless you can do a fair amount more math than we can right now. And this correlates with a lot of other measures of sophistication, but also allows for, what is going to succeed us in the year 3000? Will they be humans? Could they be like, AI, enhanced humans, or, some kind of form that we can't even understand right now, like pure software? Who knows? But if that does happen, the way I think we'll know if it's sort of advanced in the sense like, the Neanderthals aren't around. Homo sapiens is the successor of what came before us, the various, archaic hominids. And we're better at math. And so that's like one ruler, right? You can say, because everything else is sort of arbitrary. They may like stones and we have stones that we shape in a certain way, but math actually does have kind of an absolute ruler to it. So that's like one thought in terms of how you kind of measure what scientific progress looks like over the medium to long term. And I mean, there's more I can talk about, but let me stop there and get your thoughts.
I'd be curious because like Thiel makes this excellent point that kind of like crypto should be a very like technology that freedom is like closely associated with, while AI is more like surveillance state. China China doesn't like kind of like the freedom properties of crypto. So do you think there's a risk that AI being like a dominant driver of progress is a very like centralizing technology, like in the hands of like the Chinese state or like a DeepMind or OpenAI, and not necessarily by nature kind of like decentralized, because like compute and talent, like there are benefits to having centralization there. So how do you see kind of like AI unfolding on the centralization, decentralization spectrum and the risks to it?
It's complicated. So first thing I'd say is I actually think of it as a triangle, which is CCP is, like most identified with AI, BTC with decentralization and crypto, and NYT with social. And so if you think of social, basically that's not done yet. We think of social media as like mature, but the metaverse is social. And then crypto is, all the stuff that we're seeing here. And then AI is robotics and all the stuff in the physical world. So there's like three different ways. Why those three technologies, by the way? Why is it not trite? Why not talk about electric cars and, solar panels and spaceships and stuff? I love those things. Those are also cool. But electric cars, supersonic aircraft, those are almost like endpoints or devices or inanimate. Whereas AI and social and crypto are three ways to coordinate large numbers of human beings. Social and crypto, perhaps very obviously, whether it's upvotes or it's markets. It's basically, social is sort of left democracy with markets, and crypto is like, social is like left democracy with like elections and upvotes and speech and voice. And crypto is right democracy with markets and auctions and exit and so on. And then AI is actually neither left nor right democracy, but harmony, like one. Okay. That's like the Chinese model under Hu Jintao is like out of its billion-person state, one, which is a different model of aggregation. Like the democratic model is an election, and e pluribus unum comes with an election, and, Kenneth Arrow and all this stuff in aggregation functions. The market model is let the market decide. And the AI model is harmony, which is slurp all this stuff into just one all-seeing, all-knowing AI God, basically, right? And that's kind of what CCP is building, this thing that knows more about any human than anything has ever known before. I don't know what the full implication of that is. We're just at the very early days of this. I don't necessarily think it has to be AGI to be concerning. It's something that can just script all the drones and hunt any dissent more than anything we've ever seen, which is obviously troubling because, it's like an unbeatable order in that sense, right? And if it's a bad order and an unbeatable one, that can be bad. Even if it's a good order can turn bad over time, So it's pretty complicated. And with that, so first identifying as a triad, the other thing I'd say is crypto can be sort of corrupted or repurposed for centralization with the CBDCs and so on. But AI can also, of course, be decentralized with federated machine learning. Or if you're seeing, there's knockoffs of DALL-E 2 and other things that happen very quickly. They're not as good, but they very quickly get out there. And moreover, these models are difficult to train, but as you know, relatively cheap to evaluate. And so they're literally just bags of coefficients. And probably in the fullness of time, they'll either get reverse engineered or hacked or something like that. Once it's known that it's possible, it's probably possible for other people to catch up. I'm not sure how defensible those things are, especially with like the one-shot stuff or zero-shot stuff. Like the whole point is that you don't need as much data to train or what have you, right? So we will see. So that's like the second order. There's decentralized AI and there's also centralized crypto. All right, let me pause there and get your thoughts.
Gotcha. I'd actually like to switch gears for a minute and just talk about how to think, right? You're pretty well known for this, but How would you say you draw from history, as you have been throughout a lot of this interview, to make predictions in technology? And what are the biggest challenges in doing that?
Well, I mean, the thing is, there's different ways to pull from history. And one of the things I consider an unsolved problem is to determine whether a historical analogy is accurate. Okay. What I mean by that is, if you analogize an RLC circuit to a spring with dash pot, okay, you get a second order harmonic differential equation where you can exactly analogize the R, the L, and the C to the spring constant and the dash pot and so on, right? It's like, it's not just an analogy, it's a mathematical analogy where you have a second order differential equation. That's like one of the most famous mathematical analogies, Feynman talked about in the Feynman lectures and whatnot. And mathematical analogies are the best kind because there is an isomorphism between the objects here and the objects here, and manipulating these gives you insight into these and vice versa. Historical analogies are always more fraught because, people will just argue, oh, this guy is just like Hitler or whatever, right? And everybody will feel, this is like about their strength of assertion on it and so on. I do think that at some point we might become smart enough that we could say, something in between the extreme micro of like an RLC circuit versus a spring and dash pot, and the extreme macro of like a current population configuration is like a market configuration. Okay. So that is something which is not like inanimate objects, and it's not millions of people across a very long period of time, but it's like market microstructure, like market depth. So that's not millions of people, but it's often many thousands of people or even hundreds of thousands of people. And it's not that controversial to say, oh, this set of market dynamics, this evolution of prices, this order book over time looked like this other one, right? There's people who just like hold order books over time, and there might be certain crowd phenomena that's like, oh, this guy comes in with a big sell and everybody gets scared, and the liquidity leaves, or you could have something like that. I'm sure the HFT guys have a whole menagerie of common, shocks to order books. Okay. And that's a little bit like an intermediate thing between, the history of a circuit and the history of a population. It is the history of a mesoscale thing where you've been able to run the experiment enough times. They've seen exactly how this order book will collapse in certain circumstances. And the mathematical analogy part becomes easier because in theory, you could, especially if you had full information in every, price quantity pair in the order book, if you could map that to the new order book and you could kind of see how similar they were, you could you could make a mathematical analogy. And I think eventually it's possible that, we're at the beginning of sort of digital history, as I mentioned in the book. And as long as we don't blow ourselves up, most of human history actually extends into the future. And it's hard to think about it like us being at the beginning of something because we think of ourselves as like the culmination. Maybe we're at the beginning of something. And if that's the case, then the ability to look at a huge number of humans is almost like molecules in a fluid and say, this state is like a certain laminar state, or this state is like a certain turbulent state, and therefore we can analogize it to previous periods. It would be sort of like in fluid mechanics, making, oh, this is, laminar flow and this is turbulent flow, and I can analogize it to what I did before. So identifying that historical analogy part, like that mapping, that isomorphism recognizer, as the most difficult part to convince other people of, agreeing that part is the most difficult. Subject to that, if you do think that there's a configuration of humans today, and the reason I use configuration is if you almost start thinking about humans as like billiard balls that can, just like atoms, smack into each other and do various things, and they'll do certain things under certain circumstances. There's like configurations of humans that acted in certain ways in past history that might act in similar ways today. In a sense, as the saying goes, human nature doesn't change. Robot nature may change, but human nature doesn't. Robots are getting way better. Algorithms are getting better. That is a new thing under the sun. But human nature doesn't. And so if you can make that analogy and you can find a previous configuration, you can say, well, today is like yesterday. And I talk about this somewhat in the book where I say, look at the macro level. I can give about 30 examples that show that we're decentralizing in a way that's similar to more the early 1900s, late 1800s than to 30 years ago. Like our future is our past. It's like peak centralization 1950, and you go more decentralized in either direction. Okay, so that's high level of how I think about, the use of historical analogies. Go ahead.
Sure. Yeah, let's dig in a little bit more on that, right? Like, to what extent do you approach history as being cyclical, right? I think it's John Hillis who has some great writing on this, where he talks about these broad historical cycles of centralization and decentralization being created by sort of the advent of information technologies over time. Do you align with that cyclical approach to history in the context of technology, in the context of the way you approach prediction making?
So it's funny, and it's almost trivial, but basically I have this whole thing in the book where I talk about the helical theory of history. Okay. Mm-hmm. So the linear theory it's just a line. Okay. Z of t equals kt. Okay. We're just advancing. We're just progressing. Maybe it's some wiggles, but for the most part, the arc of history is long, but it bends towards progress. And then the cyclical theory it's a parametric curve, right? X of t equals cos t, y of t equals sine t, and you're just going around in a loop, and we just come back to where we are. And that's like the, hard men create good times create weak men create, so hard men create good times create weak men create hard times create strong men, something like that, right? I'm getting the hard, but you get my point. And as I talk about in the book, there's, left, right, and libertarian versions of that cycle. The left version would be the revolutionaries, go and push and make the revolution, and then a Stalin compromises it, and then, we're oppressed again, and then there's another revolution, like that, right? And so the cyclical version has something to say for it. That, one of the reasons is humans are, on the order of 70-something years old. And so as things drop out of human memory, on the order of 2 generations, certain kinds of things seem to repeat. So there's like fourth turning, and, there's, what's his name? Peter Turchin stuff. I think is the most quantitative look at this. Ray Dalio, Turchin, and Strauss and Howe are all worth reading for this sort of Asimovian psychohistory look at things. Okay. But the way I kind of think about it is a V3, which is helical, right? And so now you can kind of superimpose those, right? Z of t equals kt, X of t equals cos t, Y of t equals sine t. And now you've got a corkscrew that's maybe going up from the origin. And there are cyclical aspects. We're also making progress in some ways. We're not guaranteed to do so. It's possible that spring goes flying like this. If you watch the Collapse of Civilizations podcast, it's sobering to realize that civilizations can collapse, that our current civilization could collapse, that others have before, that in a sense, we're like the guys who got to the last level of a video game and were made the most successful up to this point. I don't think previous human civilizations, to our knowledge, had gotten to like space travel and so on. But that may just mean that like our final flame out is like really chaotic. So it's actually good to decentralize, to have eggs in multiple baskets, to get to other planets. And, it's what Alon talks about backing up humanity. One thing I actually think is underappreciated that the internet may allow us to do is to actually encrypt humanity. And what I mean by that is it used to be that there was terra incognita, that say like, here would be dragons on the map, parts you didn't know about, parts of the world you didn't know about. And I actually think that we're at peak visibility, like right around now, in terms of being able to see the faces of all the people on the other side of the earth. You never used to have something where 3 billion people could find out what 3 other billion people look like. That, like Google Images, like that never used to happen before. People were never that visible to all other humans, like very few people's photos were printed. Photos are relatively unusual. People essentially were not in the panopticon to the extent that they are. And I think a reaction against that Chinese control will be the secret state, the encrypted state, where just the very fact that you're a member of a digital society is not even known to anybody other than other members. That NFT locally with your AR glasses, you can see that that person has the same glowing sigil that you do, but it's not disclosed to anybody else. That territory, that building is an unmarked building, and you basically start to encrypt the real world. And if you think about it, if you didn't have Google Maps, if you didn't have those overlays, if you didn't know, you wouldn't know what many buildings on the street were, who was in those offices or what have you. It would basically be something where you couldn't open the door, you wouldn't go in. So we're at sort of peak visibility now. And one of my, I think, out of the money predictions is the re-encryption and pseudonymization of the world. And why does that actually matter? Well, it's an intermediate between now and getting to Mars. Why? One of the things Steve Jobs did within Apple is he pushed secrecy. Why did he push secrecy? So you could have multiple teams that didn't know about each other, that were working on the same thing, but they were innovative since they couldn't copy from each other, right? And they didn't feel competitive with each other because they didn't know about each other. So they weren't mimetic, right? They were decentralized. And Peter Thiel and Gerard and so on talk about mimesis a lot, like basically copying people. And mimesis can be good in the sense that that's how you learn language, that's how you learn skills. You're copying other people doing things. Copying isn't always bad, but when you look at many kinds of things that people fight over, like famously 54-40 fight was a border or an almost border war between the US and, what at the time, today we'd call Canada. I forget if it was actually Canada at the time or like still British Canada, but 54-40 fight was that the Americans wanted the border between the US and the northern, I think I said as Canada was like British Canada or something like that. The antecedent of Canada to be at the 54th parallel and 40th minute or whatever it is with latitude. It's actually at like the 49th parallel. But the point is, unless the thing was mapped, people wouldn't even be able to fight over something like that. And you might say, well, how could you possibly go away from maps? And one point I make in the book is we can see the Franco-German border, right? That border had, the Maginot Line was built, people invaded back and forth. It's this huge thing, militarized, there's landmines, all kinds, not anymore, but there were all kinds of crazy stuff happened there. We can see it. People know basically who's on either side. You can go on Google Maps and you can kind of get a sense, are you like basically a borderline German, a borderline French person, whatever, okay? But we don't see the Twitter, Facebook border. These gigantic things, which are both individually much bigger than France and Germany put together, right? Twitter's like 300 million, Facebook like 3 billion. The people who log onto Twitter 100% of the time are all the way in Twitter land. People log into Facebook 100% of the time over here. But those folks who the two social networks compete over, who might, let's say, log into each about 50% of their time online, and I'm just using that as one metric. You might have other metrics of what the border is. Those people are not known to either party. Right? There's this giant, I don't know if it's 50 million or 10 million, or if it's totally disjoint groups. We just don't know what the size of that border is. We also don't know the size of the border between Facebook and TikTok, right? But the other day, actually, somebody pointed out that, they're actually, here, let me see if I can find this tweet. They pointed out that Facebook, Instagram was trying to block the TikTok videos from being published. Let me see if I can find this.
Go for it.
Okay, I can't find this now. But point is, Meta tried to block TikTok videos coming in, right? Okay, great. We've got a hard stop. Good. Let's finish up.
Do you have one more time or?
No. I actually do too. So why don't we
maybe as a last question, given our audience are kind of builders and people in decentralized science, and you are kind of like one of the most successful builders in the world, like having built both in the sciences and in crypto, what would you recommend kind of like the piece of advice maybe to people that want to build out also like some of the visions you described for decentralized science? How should they approach it? Of course, there's like the best practices playbook of how to build startups, etc., but it might be different for decentralized science. Like how would you in general just as general advice to a builder in DeSci, what would you?
I've got a very specific thing. Build a demonstration of truly reproducible research. Take two statistics papers where one cites the other, okay, and maybe actually uses a function from the other. Have them both be on chain, maybe with the data and stuff on Arweave, and just show how you did that. That would be a huge breakthrough. Just focus on something very specific. Then we've got that proof of technological fire where we can show, here's a paper, here's another one. It's like ARPANET, sending like the first packet, right? That first on-chain citation as a function call where you have composable science will be a milestone. And I think that's like a very concrete thing that somebody can build. It's not really that hard to do. It's just kind of figuring out like how to put the code on chain or on some data store. If you want to use Solana, whatever, that's totally fine. Do it however you want. Point is, use some kind of decentralized platform to show that you can get composable science, like you can get composable finance.
Awesome.
Amazing.
I think that's just about it for us. Balaji, appreciate the words, appreciate the time, appreciate the advice at the end there. 1729.com, thenetworkstate.com for anybody looking for the book. It's great.
Yep.
Any final words?
Well, I'm on Twitter at BalajiS. So follow me there. And if you do build anything in truly reproducible research, I should say, which is on chain, very interested in seeing it. And if you're doing things that are like Molecule DAO, I'm interested in that too. Thanks.
Maybe as one last question in that direction, do you have specific like recommendations for like a book or resource like to dive into like the sciences, or like something you would recommend you haven't recommended before?
Oh, well, I like the Princeton Guide to Mathematics. If you ever do have to be in solitary confinement, that is a book to bring with you. That and a bench press, you'll be okay. All right. And there's like COVID or whatever, right? And I think we'll also have, if you just subscribe at thenetworkstate.com, I'll be pushing out a bunch more free content and chapters that'll cover a bunch of these topics and have more references there.
Amazing. Thanks for taking the time. It was a pleasure.
Thank you.
Thanks, Balaji.
Okay. Bye.
Thanks for tuning in. For more information about this podcast and about Molecule, check out the show notes below. If you have any questions and want to get into a deeper discussion about today's topics, feel free to visit our Twitter or our Discord. You can find all the important links in the description and show notes below. Also, if you're a researcher seeking funding, if you want to start working in a biotech DAO, or if you're an investor, please visit our website, molecule.to, for more information. Thanks again for tuning in, and we'll see you again soon. Bye.